So the first type of reaction that we will be looking at are precipitation reactions. From the word, it means a reaction in which an insoluble substance forms and therefore crashes out of solution. That's what basically a precipitate is. It's an insoluble substance. So in order to know whether a precipitation reaction actually takes place between two ionic compounds, you must know solubility rules. Okay? Now, precipitation reactions are also called exchange reactions, or in some cases, double displacement or metathesis reactions. Basically, it's simple to write precipitation reactions. If you have a compound AB, such as this one, okay, where A plus is the cation and B minus is the anion, when it reacts with CD, they basically trade partners. Okay, so here A becomes partnered with the anion D, and then the anion B gets partnered with the anion C plus. Okay, now again, for precipitation reactions, however, you must have this insoluble salt. Okay, this insoluble salt, and then this one is a soluble salt, and then again here you have silver chromate as the insoluble salt. Okay, you can immediately see precipitates just because they crash out colorfully out of solutions. Okay, now it will be up to you to basically memorize these solubility rules. Okay, so this is a slide which contains all of the solubility rules that I have collected in all of my references. Now when it actually says here slightly soluble, let's say for example silver chloride, which is in all salts of chlorine, bromine, and iodine are soluble except silver chloride. Okay, so when we say that something is not soluble, at least that is true at the macroscopic level. Now at the microscopic level, there are some trace amounts of these insoluble compounds which do dissolve in water. Okay, but again, those trace amounts are very negligible, that we can just look at the compounds in total to be completely insoluble. Now we will look at solubility rules again if you're going to proceed with the second saga of this course in chapter 15 of Chem 106. But for now, all of these compounds that are in these basically, and these with some exceptions of course, are insoluble compounds. And again, as we have said earlier, insoluble compounds, at least for this chapter, are not strong electrolytes. Okay, some examples of solubility or precipitates crashing out of solution. So for example, if you have silver compounds, silver nitrates are very soluble, but silver chloride and silver hydroxide are insoluble. Okay, some other compounds here as well, I'm going to just let you look at them. But basically what happens at the molecular level can be explained by this reaction or by this cartoon, wherein initially you have silver nitrate and potassium chloride breaking up into ions in solution. Okay, now they do break up in solution because they're soluble solids, okay, soluble ionic compounds, and therefore they're strong electrolytes. Okay, now when silver reacts with chlorine, okay, in the metathesis reaction, okay, you actually form silver chloride, which does not break up into ions and instead crashes out of solution. So this will be silver chloride. But potassium nitrate is soluble in water. Okay, so potassium nitrate will still actually dissociate into potassium and nitrate ions in solution. So here potassium nitrate is actually still a strong electrolyte, whereas silver chloride is not. But again, one thing I wanted you to appreciate here will be basically this diagram just shows us that in essence, actually, the nitrate ions, okay, and potassium ions did not really participate in the reaction. Okay, basically the only ones which participated in the reaction are silver ions and chloride ions. Okay, and basically what we have just said can be described by writing out molecular, ionic, or actually I'd like to call this total ionic. Okay, total ionic, and then this one I'd write is the complete ionic, or complete. Okay, okay, just because that's what I'm used to calling them. Okay, so when we write precipitation reactions, we actually write them using these three equations to illustrate or to basically draw a clearer picture of what's happening in solution. So the complete equation actually tells us, or the molecular equation basically also tells us what's happening, or what exact rather ionic compounds we start with. Okay, you start with these soluble ionic compounds and end up with an insoluble salt. Okay, and then you end up with also a salt which is soluble. Now in the complete ionic equation, or sorry, in the total ionic equation, what you actually do is to break up everything which is soluble in water into the individual ions that they dissociate into. So for example, lead nitrate breaks up into lead 2 plus and nitrate ions. So ammonium sulfate breaks up into ammonium and sulfide. Okay, now lead sulfide does not break up, so we're still going to write them as lead sulfide. And then also ammonium nitrate breaks up into ammonium and nitrate ions. Now similar to a math equation, notice that that on both sides of the equation, ammonium appears on both the left and right side. So we can actually cancel it out. Okay, again, similar to a math equation. And the same thing goes with nitrates. They appear on both sides of the equation. Okay, so in effect, as we have mentioned before with silver chloride, ammonium and nitrate ions here do not participate in the reaction. And they are called spectator ions. Spectator ions, again, are the ions which are cancelled out in the total ionic equation. Okay, now for the net ionic equation, it's basically everything that was not cancelled out from the total ionic equation. So we have here lead 2 plus, and then sulfide 2 minus, going into lead sulfide. And that's how you write all of these three. Now what if no precipitate forms? Let's actually illustrate that in one example later that we are going to discuss. But let's see. For this question, I'm only going to, or for this video, I'm only gonna answer the last two questions. Okay, and then we will discuss the others in class when we meet online. Okay, so the first question is letter D. Okay, sodium bromide and rubidium chloride. Okay, so both sodium bromide and rubidium chloride are soluble in water. So when we write the complete equation or the molecular equation, okay, we're gonna write it as sodium bromide aqueous, rubidium chloride aqueous, going to form sodium chloride aqueous and rubidium bromide aqueous, or rubidium bromide, oops, sorry about that, aqueous, oops, there we go. Okay, now again, we were able to get into this reaction by just swapping cation and anion pairs. Okay, that's what we did. All right, now here all of them, as you can see, are soluble in water. So the total ionic equation is just sodium plus aqueous plus bromine ions aqueous plus rubidium plus aqueous plus chloride ions aqueous. Okay, going to let's now write the products. So sodium plus aqueous, plus chlorine minus aqueous plus rubidium plus aqueous plus bromine aqueous. Okay, by the way, both equations are balanced. Now let's see what ions we can cancel out to arrive at the net ionic equation. Okay, so here sodium cancels out there on both sides of the equation. So does bromine. So does rubidium. This is Rb. Okay, and so does Yl. So we're actually left with nothing. Okay, and note again that both of these salts that are formed are soluble in water. So for cases like this, there will be no reaction. Okay, and then let's go on with another problem, letter E, which we have here for the molecular equation. We're asked to write copper 2 chloride. So copper 2 chloride is soluble in water. Okay, and then it's reacting with sodium hydroxide. Okay, sodium hydroxide is also soluble in water. Okay, and then that goes to copper hydroxide. Okay, and copper hydroxide is insoluble in water. Okay, plus sodium chloride. Okay, now this equation is actually not balanced yet, so we have to put a 2 before sodium hydroxide. Okay, and also a 2 before sodium chloride, and that actually balances out the equation. Okay, now the total ionic equation for this one should be copper 2 plus aqueous plus chlorine ions aqueous. Okay, I'm not gonna put here this I'm not gonna put that stoichiometric coefficient yet. Instead, I'm just going to focus on what sodium hydroxide breaks up into. So plus Na plus aqueous, okay, plus OH minus aqueous, going to form copper hydroxide stays intact, copper hydroxide 2 solid, okay, plus sodium 2 plus sodium plus chlorine minus aqueous. Okay, and then to balance this equation, we just need to put a 2 before hydroxide. Okay, and therefore the net ionic equation, let's see what cancels out. So chlorine cancels out, copper does not. Then we also have sodium canceling out. So we're actually left with the formation of copper hydroxide, copper 2 hydroxide, that is Cu2 plus aqueous, plus 2OH minus aqueous, and then that leads to copper hydroxide. This is solid. Okay.